Okay, so talked to Mack the other night, and he asked me about whether or not he thought it was possible to stop a charging wolf, basically like grabbing it by the neck. And so he asked me what I thought. I said I didn't know, and I got bored today, so I did the math. So this is, could Mack Boyd stop a charging wolf with one hand? All right, so let's go through. We got subject A, which is the average male gray wolf, weight of about 100 pounds, corresponding to 45.4 kilograms, top speed around 35 miles an hour or 15.65 meters per second. And then we got Mack Boyd, weighing about 225 or 102 kilograms. So really the question is, who can generate more force, the wolf or Mack's one-handed grab? Because the idea was to basically grab the wolf by the throat. So breaking it up, the first part, let's calculate the force of the wolf. So at top speed, the momentum of the wolf can be calculated by multiplying the mass times the velocity. So that just comes down to 710.51 kilogram meters per second. All right, so then we kind of have to make an assumption. So given that Mack wants to stop the wolf almost instantaneously as he grabs the wolf by the throat, we'll say that he basically has a 1 second to stop the wolf from the time that his hand makes contact with the wolf. So given that, we can actually calculate the force, because force is equal to mass times acceleration. If you add a time factor to both sides of this equation, what you end up getting is just mass times velocity, and that is momentum. So force times time is equal to momentum. So dividing momentum by time is equal to force. So if our time period is 1 second, then the force is 710.51 newtons. So that's the force of the wolf. Part two, given that Mack is at a standstill, we got to calculate the force that he can basically push with one hand. So like I said, he's not using his whole body, he's using just one hand. So basically what I said was, what's the average bench press of somebody Mack's weight? It's around 94 kilograms. So dividing that by 2, you can say that one hand can basically push around 47 kilograms, right? So just that number by 2. The speed of an average punch is around 8.94 meters per second. So the speed at which Mack could move his hand. So basically calculating the force of Mack's hand is equal to the weight times the velocity over the time, and that's only 420 newtons. So basically from a standstill, Mack would get eaten. He would be overcome by the force that the wolf generated, right, which was 710 newtons. But let's say that Mack was running at the wolf, right? So basically charging to meet the wolf. So they say that gray wolves normally stay around 15 meters away from their prey before they attack. So given that number, let's say that Mack and the wolf meet halfway in between that distance. So how much force could Mack pick up prior to meeting the wolf at a distance of 7.5 meters away? So the average acceleration of a male is around 15 feet per second squared. It's a little higher than that actually, but that was for like a 180-pound man, was around just below 20. So using that number for Mack, that corresponds to 4.6 meters per second squared. So then the force that Mack's body is generating at that speed is 470 newtons, right? Just as mass times his acceleration. But let's adjust that, because Mack is, again, he's not throwing his whole body against the wolf. So adjusting that, we'll subtract 20% from that number. So basically, we can argue that Mack's just momentum, or his force created by his own body weight, putting into his left arm, is around 376 newtons. So then that's Mack's adjusted weight. So that adjusted force. So that adjusted force plus the force that we previously calculated for Mack's hand, that number can be upwards of 796 newtons, which in theory could mean that Mack could stop a charging wolf if he was in shape.